Hello all, in this video we are going to see about measure of dispersion, that is coefficient of variation, and also standard error and confidence interval, and how we are going to calculate it and what it means when we are dealing with the numbers. So as a continuation of the last session, we have seen about the measures of dispersion. In that, the penultimate measure was the mean deviation. The mean deviation, which is given by the formula sigma x minus x bar divided by n. So it is the summation of the mean deviation divided by n. We have mentioned about this coefficient of variation, but we haven't explained there. This is the last measure of dispersion in our list. So that is the coefficient of variation. It is given by the formula standard deviation by mean into 100. So it is expressed in percentage. What this coefficient of variation indicates is the level of variability. That is, if the standard deviation is so high, more than the mean, then it exceeds the 100 value. So that indicates that values are highly spread towards the extremes, and hence the chance of it being normal distributed is less. As a general rule, if the value coefficient of variation is somewhere between 50 percentage, then it will be a normal distribution among the numbers, and if it is less than 20 percentage, then definitely there is a higher chance of the numbers being normally distributed. So that is the first problem we are going to see, coefficient of variation. Next, we move on to the important parameter called standard error of mean, otherwise called as standard error, otherwise called as sampling error. So what we do in research is, out of the total population or the study population, we take only a few sample for our study. The method by which we take this sample is called as sampling. And with this sampling, we get a mean value. Through our study, we get, and we try to generalize to the entire study population. So when we try to do this generalization, we may not be 100% valid. That is, we may not be accurate. We may make error. That error is called as sampling error. That is, in other words, instead of we measuring the entire population, we are including only this sample for our study, and we are trying to provide results, generalizing the results to the study population. So in this process, we may make an error of calculation. That error is called as sampling error or standard error of mean or standard error. So that standard error is given by the formula standard deviation divided by root of n. When you are dealing with proportion, what is the difference between mean and proportion? When we are measuring hemoglobin in the community, that is called as hemoglobin grams percentage, then that is a number. So we calculate the mean of that value. When we are calculating the prevalence of anemia or proportion of anemia, then that is a proportion or category. So there we use this term proportion or prevalence. So in that case, the formula will be root of PQ divided by N. So that is root of PQ divided by N will be the formula for standard error of proportion. We have standard error of mean as standard deviation divided by root of N as the formula. And as we all see, this sampling error, if you look at the formula, the sampling error is inversely proportional to the square root of the sample size. And what literally the standard deviation means is the variability. So as long as your values are highly variable, then the chance of you making the sampling error is high. So when you are having a small standard deviation, the sampling error also will be small. And as you increase the n, that is the sample size, it is inversely proportional. So higher the sample size, lesser the sampling error, and lesser the sample size, higher the sampling error. Same way, we have in standard deviation, we have one more n here. So again, that also will add. So that is the standard error of mean or sampling error. So that is given by the formula standard deviation by root of n for mean and root of PQ by n for proportion. Then we have to calculate the confidence interval, that is 95% confidence interval we say commonly, that is given by the formula mean plus or minus 2 standard error, or prevalence plus or minus 2 into standard error will be the 95% confidence interval. What it literally means is, through our study we have calculated a particular mean value from our study. We have calculated a standard deviation, we have calculated a standard error, and we calculate a confidence interval. Suppose let's say we calculate the mean as 11, and suppose let's say standard error is 1 for your study, then we can say it is 9 on this side and plus 2 on that side will be 13. So we can say, in my study I have conducted through this sampling and I have got the mean value as 11. If you make a different kind of sampling in this study population and you repeat the same methodology, 95% of the times the true value lies between 9 to 13. So that is what it really means. That is the confidence interval, or 95% confidence interval. That is 1 in 20 times you get values out of 9 and 13. That is the inference of confidence interval, that is plus or minus 2 standard error on either side of the mean or the prevalence. That is called as standard error. So in this video we are going to see about the problems of the measures of the dispersion, that is the last measure of dispersion, that is coefficient of variation, followed by your standard error of mean and standard error of proportion in two different problems. First we move on to the coefficient of variation. So here is the coefficient of variation problem. Calculate the coefficient of variation of the following data and compare the variations. So they have given the mean value, the standard deviation, the range and all. Just range is here to confuse us. We know the coefficient of variation formula is given by standard deviation divided by mean expressed in percentage into 100. So that is the formula of coefficient of variation. So we need to compare the coefficient of variation. So here we need not consider this range, but many times what happens is, in your problems they may not directly give this mean and standard deviation. So they may give a set of values for two parameters or two groups. So we may have to calculate the coefficient of variation, mean and standard deviation first, then we may have to calculate the coefficient of variation. So here in this question they have given height of infants, the mean is 75 centimeter with the standard deviation 5.2, weight of the infant is 9 kilograms and with the standard deviation of 2.5. So we calculate the coefficient of variation for height first. So then we need to put up the standard deviation divided by mean, that is 5.2 divided by 75 into 100. So we get 6.96 percentage, which is here. Then we have the coefficient of variation for weight of the infants. So that is standard deviation 2.5 divided by the mean, that is 9 into 100, which will again yield 27.7. So that is present here. So what it literally means is, as I said earlier, coefficient of variation is the expression of the variation of the variable compared to the mean value. So we need to write the interpretation as the coefficient of variation of weight of the infant is higher, that is 27.7. Here it is 6.96, higher than the height. So hence coefficient of variation is independent of any unit of measurement and thus useful for comparison of variability in two distributions. So we need to compare between the height and the weight, and we have to say weight is more variable when compared to the height. So that is what we are going to infer from this problem. And please remember that here it is given mean and standard deviation calculated compared for two groups, but sometimes they may give the individual values here, and we need to calculate the mean and standard deviation, and we need to calculate the coefficient of variation, and we need to arrive at the inference of this coefficient of variation between the two groups or the two variables. Now we move on to the next problem, that is confidence interval and standard error. Here is the problem for standard error and confidence interval. So the marks obtained by 10 individuals in subjects are as follows. So they have given the marks here. We need to calculate the mean deviation, standard deviation. When we are calculating the standard error and confidence interval, we need to calculate the standard deviation first. So even if they have not asked about standard deviation for standard error, you need to calculate the standard deviation first. Then only you can calculate the standard error. So here we need to calculate the mean first. So mean is given by the sum of all observations divided by number of observations. If we sum it up, it will be 306 divided by 10. So that will yield 30.6. Then we need to calculate the mean deviation here and the standard deviation also. For this, we need to put a table. That's what we have said. In that, we need to put x minus x bar, the whole square. Then we need to have a summation of this x minus x bar and summation of x minus x bar. If we divide it with 10, that is called as mean deviation. If we divide it with n minus 1 and take a square root, that is called as standard deviation. So that is how we calculate. So same way, if we do a table and put a value here, it will be 32 divided by 4, 32.4 divided by 10. So that will be 3.24 will be the mean deviation. Again, for standard deviation, if we do this sigma x minus x bar the whole square, that will be again 176.49 root of 176.49, that will be 4.427. So that is the standard deviation here. Then after calculating the standard deviation, we need to calculate the standard error, which is given by the formula standard deviation divided by root of n. Here it is 4.427 divided by root of n is root of 10. So if we do that, the standard error will be 1.4. So this is the standard error, and we need to calculate the confidence interval also. This is given by the formula mean plus or minus 2 standard error. So which means mean is 30.6 here, plus or minus 2 into 1.4. So which is 2 point, which this 2 point, this is 2.8 plus or minus 2.8, 30.6 plus or minus 2.8, which will yield 27.8 to 33.4. So what it really means is, it is the interval where you believe the true value, true mean of the study population lies if you repeat 100 times, and the chance of you being wrong will be 1 in 20, that is 5 percentage. So 95% of the times you are confident that the true value lies somewhere between these values. This is called as 95% confidence interval. Here we have used the formula standard deviation by root of n, and here mean plus or minus 2 standard deviation, since it is a mean. Suppose sometimes they have the prevalence or proportion. So in that case, we need to use root of pq by n. So we calculate standard error like that, where p is the prevalence. Suppose let's say prevalence of anemia is 25, p will be 20, q will be 100 minus p or 1 minus p they say. So if it is 25, then it will, q will be 75, because q is 100 minus p or 1 minus p, based on how you are taking the prevalence. So in this video, we have seen about the last measure of dispersion, that is the coefficient of variation, which was given by the formula standard deviation by mean into 100. So basically, it is the measure of the standard deviation expressed in percentage in ratio to the mean. That is the coefficient of variation. The next we have seen about the standard error and confidence interval. Standard error is the error which is caused due to the sampling. So instead of we doing the research in the entire population, we have restricted only to the sample. Because we have restricted to the sample, we may not be accurate with the results. So the truth or the actual results may be something else. So we try to match the results of the true value with our study value. So for this, we use the term called as standard error, which is given by the formula standard deviation divided by root of n for mean, and if it is for proportion, then root of pq by n. And then we calculate the confidence interval, that is given by the formula mean plus or minus 2 standard errors that is two standard error on either side of the mean will be your confidence interval. So only 1/20th of the time the values can go beyond that level is called as the 95% confident interval. So hopefully you have understood about the coefficient of variation, standard error and confidence interval. If you like this video, please click on the like button and share it with your friends. Thanks for watching this video.